Ladies and gentlemen, please welcome Principal Solutions Architect, Bill Shin.
Hello, and thank you for coming back to the security track. I know everyone loves security. It's everyone's favorite topic. So judging by the title, you can tell that I picked the title, not marketing. So I'm fully responsible for how incremental that sounds. And while Stephen helped you become an IT hero, I probably need to come up with something because security is awesome. So I'll come up with a more exciting title. We've done lots of talks where we highlight all the services, all the certifications, and the shared responsibility model. We assume, because this is the Enterprise Summit, this is the second year that we've done this, we assume that the basics are up on reInvent, from our reInvent slides. Stephen Schmidt, our CISO, gives a great introduction to security talk. But this is the Enterprise Summit, and I'd like to take a slightly different approach to this topic. Ultimately, we'll still highlight some of the best security practices and best security services and features in AWS, but we also assume that you're somewhere along the journey. Whether it's just exploring AWS or actively running workloads in the cloud, the shared responsibility model does make up the foundation of how we operate together. We take care of a lot of the security controls in the data centers and the way we operate our services. And you control and bring familiar controls to the workloads in the cloud. But again, our customers are expecting us to be more prescriptive. And not just in the technical architecture, but toward ways in which they can adapt their organizational behaviors and help evolve their security programs, the leadership styles, and the processes so they can take advantage of the cloud. So today, we'll talk not just about technology, but about how modern security organizations have evolved. And we'll hear the story of how key security processes look today and compare them to a world where cloud exists in a faster moving, far more secure enterprise. So why does security come first in enterprise cloud adoption? I have the pleasure of working with all of our North American customers, or all of our America's customers, and it's almost always the first topic that comes up. And you could say, well, it's because I don't want to be in the news. That's obvious. But we have to, the approach we'll take today is to kind of ask the 5 whys and get to the root cause or the real reason why we think this comes up first and how we can help. So by unpacking this question, we'll see how you can get greater agility and greater security on AWS. We bring it up. That's why it comes up first. If you don't bring it up, we do. It's job zero for Amazon Web Services. And we don't have a business if we can't secure our services. We also know it's going to come up eventually. The CISO will find out that you're using the cloud. Trust me, I know. I talk to them. And we want to get ahead of it. We want to prevent anti-patterns from emerging. We want to introduce new ways of improving security as you transition workloads to AWS. And most of all, we bring it up to earn the trust of our customers. Your data on AWS represents your business and your livelihood. The trust with your customers, and the privacy and security of real people. For many enterprises, even those several months or even a couple of years into their moves to the cloud, there's still new opportunities, and this can still be new territory as you move more and more critical workloads to AWS. If you've operated data centers and traditional networks for decades, some of this might feel a little bit new. A software-driven environment, an API-based environment, services you access to provision resources, that can feel a little bit new. And we want to guide you through that. We also know, because we hear it over and over again, that customers want to maintain a sense of control. So we help guide them as they chart this new territory. Lastly, enterprise security has always been just plain hard. And our customers want to get ahead of it. So raise your hand and ask yourself if you wrapped up your last audit with your regulators or your internal auditors and said, oh, that was easy. That was great. I loved it. It was fun. I don't hear that very often. So it's been hard. Enterprise security, there's large budgets, there's large departments, there's a big commitment of resources to it because it's traditionally been very hard. It's a cost center. So getting prioritization requires Herculean leadership efforts. The threat landscape and sophistication of attacks is always changing, and very quickly. And the regulatory environment is changing, particularly as you move and expand your business globally, which is why so many customers come to AWS, is to expand globally. And as you enter new markets with different regulatory and data and privacy requirements, security gets harder and harder in traditional environments. So the first question of, why does security come up first in cloud adoption, Is it because security is hard? Well, we'll see. Whoa. Yep. So why is it traditionally so hard? Because it requires so much planning for anything security related. And those planning efforts can take weeks, months, or even years sometimes. If you have a couple of examples. So if you look at most Fortune 1000 companies with a formal security program, they have multi-year security strategies that extend out sometimes 3 years. Many work streams concurrently happening and prioritized hopefully by risk, with some projects taking over a year because of limited resources. Risk assessments require planning. They have to be inserted into the PMLC and the SDLC processes or planning stages of enterprise IT delivery. And these stage gates are designed to identify high-risk work and ensure it's properly managed and controlled. Lots of documentation, data gathering is all required to get through these stage gates. And IT security changes usually require CapEx justifications as well. In many cases, it's large hardware appliances. You have to hire people. They require spreadsheets and presentations and lots of finance committee meetings. This makes it traditionally very hard. So for example, I used to work at banks for probably 12 years, and I was responsible for running the SIM infrastructure, or the security information and event management infrastructures. As the businesses would grow or we do acquisitions, the amount of log data that we could expect to intake to the SIM platform was something that was very, very hard to predict. So we would do our annual budgets based on anticipated growth of logs, and then the business would acquire something huge and start sending tons of security logs to us that it was very difficult to keep up and anticipate that. And if you get it wrong, if you get your planning wrong for something like that, you possibly weaken a control, which is why it's very difficult, and you end up either gating the business or potentially weakening your controls. So compliance planning. Obviously, there's an annual audit cycle for many regulated businesses, but just the control planning, the control selection, deciding what artifacts to give to your compliance teams and your regulatory auditors, that can be time-consuming and very challenging. Change control, everyone's favorite subject. So every change, especially security-related changes, need usually in enterprises go through some sort of change advisory board or a CAB or a weekly review meeting or a monthly review. These attempts pretty much have to be carefully planned to perfection, lest you be asked to return to go, do not collect $200. And even the changes that are designed to and intended to improve security have to take careful planning so that they get through the change advisory boards more quickly or more effectively without being denied. So this slows down the pace of projects and business feature flow, and it makes anything security related hard to even start sometimes in traditional enterprise. So the second question, why is enterprise security traditionally so hard? Is it because it requires lots of planning? It just takes a long time? Well, why so much planning? Because there are so many processes involved in enterprise security planning. There's so many different teams across the organization, and security-related efforts often involve more than the average project. You end up with network security, server and systems admins, the identity team, the security operations center, compliance, vendor management. These are cross-organization projects that take a lot of coordination between teams. So as these business projects compete for already strapped resources, you end up having to manage those resources with additional processes. So you need to get no work shall be done until a PMLC ID is identified, or a project identifier, or PM is assigned, and otherwise no work occurs. So once you get that PM, or once you get that project open for an enterprise security project, you pile more and more and more value into that project because the resources are limited. What that means is that you have a higher risk project, and you put more changes with more scrutiny and more process applied to it. So you end up, it's difficult to break those down into small, manageable bits. And because each sub-team has their own process, the complicated processes all have to sync up. So you end up with built-in pause buttons and handoffs between teams, such as weekly review meetings, monthly committee meetings, security committees, those kind of things. Because each team wanting to affect progress, has to wait until the other team is ready, not when the customer is ready. So enterprise security comes first because it's hard, because it requires lots of planning, and because there's so many processes. Is that the root cause? I don't know. So why so many processes? Let's focus for a second on the good part of process, right? So security processes were invented for a reason. They are really designed to control risk. And each process has steps that perform correctly, ensure that a control is operating effectively. If you unwind each security process back to its roots and why it was put in place in the first place, it's often to make sure that you have a control operating effectively to mitigate some kind of risk. Processes are designed essentially for quality control. And today, even without all the planning of the last question, many of these processes lack real visibility into what's actually changing that could affect it a control. Paper-based processes, workflow processes that aren't connected to the real infrastructure or the real technology that require manual intervention, things like that. So this lack of visibility, such as assets, new applications, network ports open, they don't permit a culture of trust in many organizations. So what you don't allow, that's why the network team would never let the devs put an open internet server on outside the firewall or connected to the internet, because that culture of trust just isn't there. There has to be handoffs between teams and processes today. So if processes fail, controls fail. And processes are designed to detect unwanted change and to prevent planned changes from failing. So we want the intended changes to move very quickly, especially security changes. And these are the changes that grow a business and often improve security. But we put a process in place whenever a stakeholder needs to know when something is changing and when we need to ensure quality to a potentially higher risk change, so it actually ends up sometimes slowing down the intended business feature flow or the security control. So processes are put in place to detect change and prevent the impact of failure. So is this why security comes up first? Because we need to detect change and reduce the impact of failure? Well, why are these things so difficult? It's the last question, I promise. So today, it's intentionally hard in some cases. People have intentionally made it difficult on purpose to move quickly for security because they want to know when things change. You want to know when the firewall's open. You want to know when identity and access management and authorizations change. Because if you don't know about it, it might fail. And because if you screw something up, you can't easily change it today once those changes are underway, because the project momentum is going, because the technology isn't conducive to easy rollback. And we have a process, for example, so we don't screw it up, because if we screw it up, we have to go back to go and go through all the processes again. But that's sort of recursive and a little bit circular. So in reality, though, the technical parts of it, change detection is actually very hard. So in traditional environments, it relies on near-perfect asset control to know when something else goes on the network. It relies on mapping assets to business risk or data classification so that you know when an asset is affected, or you get that indicator of compromise or that log message, that that's actually an important message versus just signal, or rather just noise. It requires that systems react to stimulus and inform you when they're changed. So if you get food poisoning, for example, your body tells you in absolutely no uncertain terms that you should not have eaten what you ate. Your infrastructure, when it gets sick, it should tell you. There should be some sort of automation to inform you that because of some stimulus, there is now a response. And that doesn't exist in most traditional enterprise information security architectures. So also in traditional infrastructure, security, doing the actual change is sometimes very hard. Most of the security processes are manual. They're not conducive to automation in many cases. Vendor selection tends to be a long tail based purely just on features, not just the finance and RFPs and things we talked about before. In many cases, it's actually physical stuff, so you need to rack and stack and cable it and whatnot. It's hard to break down security projects into smaller batches consisting of iterative, low-risk changes. So these are big projects sometimes, and expanding a data center, reconfiguring trust zones and boundaries in a network, redeploying applications or redeploying servers. Those things can be very challenging, and we hear that from all of our customers. So, does enterprise security come first in the conversation because it's hard, or it requires planning, or there's too many processes? It's fundamentally, after talking to so many customers, we've arrived, and this resonates quite well with most, that security comes first because today they don't have the ability to detect unwanted change and course correct in an iterative, low-risk way and reduce the impact of failure. So, where does AWS come in? We make security faster. And you can solve some of the problems that we identified as we walked through the 5 whys of consolidating teams, having DevOps models. Those fix some of the problems. But just putting people together in a room that have different functions, so the network security team, the server team, the app dev teams, that's not enough to do it. You have to have processes and be able to change in an iterative way. So where we'll focus for the rest of the talk is knowing when things change. We make it easier to change and course correct the things with minimal risk. And we'll show you areas in AWS and where you can use the services to do that. But you say security is supposed to move slow, right? So if we have careful processes so it doesn't get screwed up. No, security is supposed to move fast. It has to. The attackers move fast, and you have to keep up. It should be the thing that moves the fastest, so you can respond and you can get ahead of risk, you can get ahead of the business with security. It should be the thing that moves the fastest in the organization, not the slowest. So that's our goal, is trying to help you make that move faster. What if you could move fast and still keep the wheels on? And I think that's the fundamental question we get asked a lot. We'll discuss the behaviors and the practices for the rest of the talk that help an enterprise security program modernize and how you can use AWS to help do that. So we start with secure and sensible defaults. Access and authentication authorization sort of make up I think, the entry to AWS. You have network security and storage security and things, but all of that, because it's an API-driven environment and everything's done through API calls, essentially, even if it's the management console or the CLI or the SDKs, you end up with an API. So everything starts with authorization. Anyone who can make a network change has to be authorized. We make available identity and access management. It's a platform that includes users, groups, roles, and policies. And it provides you an ability to make fine-grained authorization decisions for individual users or ideally roles. We'll talk a little bit about managed inline policies, which are a new feature that's relatively recent. And we'll talk about versioned IAM policies, and then we'll come back to some of the others. So this is the IAM dashboard, if you're familiar with it. Great. If you haven't seen some of the recent changes, like managed policies, we'll get into that. This is a role for DBAs, for example. So it's not a user or a group, it's a role. It's intended to be assumed by code, assumed by something like a SAML assertion, or traded a SAML assertion for the role. Or it's meant to be assumed by an instance. And this is a very powerful feature that I think changes the way that security is done, which is not having humans access things. It allows you to automate. It forces automation in the organization if humans can't access anything. And what you note up in the right-hand corner, you see the instance profile. That means that this role is used by EC2 instances directly. So when you launch an instance, you can put it into an authorization role, essentially, give it an identity and a set of entitlements for that instance itself, which means that a user on the box can use the entitlements of that instance to perform certain actions. Or your applications or scripts can use that identity and the authorizations. So in this case, this is and also notice the inline policy. So this is traditionally the way that policies were attached to users, groups, and roles until we launched managed policies recently. This means that the policy, the one at the very bottom, was directly attached to this role. So it can't be used by a user or a group or reused across things, and we'll talk about how that's changed. So this policy, the UI is a little different in the console. You can select individual authorization actions, but this is the raw policy. This is intended for a DBA. Note the bottom, the conditions. So I can give very fine-grained access and say this role can only take these actions on RDS instances with a tag of environment and a value of DR or prod. And the actions I can take as anyone assuming this role or an application assuming this role are basically to get the log files off the RDS instance. So rather than having a production access, which most people have in the enterprise if you're a DBA, they have sysadmin access or root access to a database server, or some operations team does. You can have a role that sits on an instance and gets the log files and the database parameters, which allows troubleshooting, for example, without having to actually log into the host. And it's very fine-grained. So what I've done here is create a manage policy. So prior to, in the view of the console, I had an inline policy attached to this particular role. Now I've moved that into manage policies, and I created a manage policy called RDS prod logs only. So that means now I can not only use it on that role, but now I can attach it and associate it with a user or a group if I need to as well, which means I only need to change policy in one place to have that effectively capable now by users, groups, and roles. So now I've applied this and I made it a manage policy. I've attached it to my role in place of the inline policy. Now, what's the benefit of this? A couple things. One is I can build a matrix of policies. I can have inline and managed policies applied, so I can give fine-grained access. And say I want to have one managed policy that I apply to multiple things, but then have a slight delta for one role or a slight delta for another group. I can do that with permutations now. It also means I can take advantage of versioning. So we talked about being able to make small, low-risk, incremental changes to things like authorization that I can easily roll back. And versions is a great start toward that. which means I can test things, I can stage them, and I can make small changes, but with up to 5 versions back, I can roll them back. So that's pretty powerful in terms of unlocking the problems of why security is hard. It means that if I can go back, even for things like authorization, I can make security move faster at low risk. So sensible defaults. We make multi-factor authentication available for every interactive user. It's incredibly important as you start your journey on AWS that root account or that first account you open on AWS have multi-factor authentication turned on. And every user that you have interactive access to the console for that's not coming from your own SAML federation or your own identity provider, where you've already two-factored that user, should have multi-factor authentication. Anybody with console access with just a password is not sufficient. We encourage you to use multi-factor authentication. Easy to set up with soft tokens or authenticators or a hard token. Very important. And so as you provision and take a leadership role in rolling out the cloud in your environment, if you make a sensible default for those users so that they get access and it's already secured, when you hand out a user, for example, to one of your developers or engineering team, if they are already set up with multi-factor authentication, that behavior will never go away. Sensible defaults. Also, we really encourage, and this is a conversation we want to have early on, is how do you intend to integrate the use of AWS into your workforce lifecycle management? So having users on AWS is great, but we want to make sure, and your CISO wants to make sure, that when people leave the company or change roles in the company, that their access to AWS is terminated as well. You can do that in a number of ways. You can have a manual process, but again, that slows security down and potentially puts a control at risk. We really encourage you to leverage existing investments in your SAML endpoints or your IDPs and your existing on-premises directories, which is easy to set up with trust relationships and identity providers in the Identity and Access Management Service. Or you can use AWS Connected Directory, which allows you to manage a connection between AWS and the management console and other products to something like an on-premises directory. Again, sensible defaults. So you've already got authorization built out in your enterprise. You can use it. Sensible defaults for the network. So when you set up an environment, you're using VPC, Virtual Private Cloud. It allows you to bring your own address space, your own routing decisions, your own subnets and architecture, and your own trust zones and boundaries and DMZs to the cloud. You don't need to have, it's not a separate environment if you connect it with Direct Connect or Virtual Private Gateway. It's an extension of your data center, which means you can leverage many existing controls. Again, you bring routing control. You also you want to have identity and access management policies that limit who can launch an instance into a specific trust zone. You can have different accounts for different environments. So pre-production, production can be totally different accounts. In one account, you can have multiple VPCs. Or you can even limit by identity and access management conditions which subnet you can launch an instance into. We'll talk about that with some examples. So this is a VPC dashboard. If you've seen it, great. A couple things to note. You can see the network ACL applied to that VPC, or you can see the CIDR range. Again, it's a private CIDR range, one that you would want to plan ahead for and carve out some IP space from your own existing networks. And that allows you to leverage the investments you've already made in existing on-premises firewalls as well. So it's still important to document things, even though they're in the cloud. We don't see as many Visio diagrams as we probably used to in traditional environments, but people do document their networks and their topologies, and that's very helpful. But it's also easy to use names and tags. So notice that I've named my subnets in meaningful ways. And for a security person, again, this is all accessible, and as Stephen said, an audit is an API call away. All of this is accessible through automation. So if you have 100 accounts or one account, you can get it through an API or you can get it through the console. But knowing very quickly when you log in and see where the trust zones are, that's a very important thing for a security person to know where to do risk assessments, where to do vulnerability scanning, if there's incident response, then where to focus their attention. Also notice, and I'll focus on this a bit more, the route table. So each subnet has its own route table association. And you can see I've tagged the route tables and identified them with a description of this is the route to the internet. So that means that those subnets, like my public subnets, have an internet-facing route. So what that means is that I might put my elastic load balancers there or my security services there. I have egress tiers for data out, where I can manage where my internal services and users can go. And I have bastion hosts for management. And then I have private subnets. for applications. So notice this route table. So the one that's selected on top, I have the internet route, and then the one that's selected. This one doesn't have a route to the internet. It only has adjacent routes, which means that if I want to put systems in there, they can't get out to the internet. They don't have a public IP. Even if they have firewall rules open to those instances or security group rules open to those instances that allow certain ports, there's still no connectivity to and from the internet from that subnet, unless they go through another host, like a forward proxy or some sort of outbound NAT device. So where am I going to let my developers launch instances and move quickly? Right? If I set up secure, sensible defaults for people to operate in, I can have my engineering teams move very, very quickly. They can iterate, they can launch instances, they can open security groups and firewall rules, they can attach storage, they can experiment and do a lot more very, very quickly without having to have a lot of handoff between processes every time. So if I set up secure defaults, then I can say, with identity and authorization, you can launch as many instances as you want into these private subnets. And I know, as a security professional, they will not have access to the internet unless they go through maybe a different process or assume a different role, perhaps. So you give them the entitlement, and you say, I trust you, you're going to experiment, you're going to move fast because you're going to be safe. But if you're going to take actions that may change the controls and the posture, and you're going to put something on the internet or put something behind a load balancer or launch a new load balancer on the internet, for example, then you assume a different role. You have a different identity with a different set of entitlements just in time, and only that time. So you have short-term, you have long-term unprivileged credentials that maybe you trade for a short-term privilege to launch something into a different trust zone or an internet boundary, which gives you very, very strong, powerful controls to move quickly at very low risk. And if the benefit of this too, right, is that if you put something in the wrong trust zone, in a traditional environment, it's very hard to move that back into something that's a more secure trust zone. But again, this is just software, and it's just APIs. So you move the instance into another subnet very easily by just making a few API calls, which gives you the flexibility to react and reduce the impact of that unintended change. So how do you know when things change? That was the other factor of why security comes up first, because it's difficult to know when things change. So AWS CloudTrail and CloudWatch logs together, we'll start with those, give you a really clear indication of what's happening in your infrastructure. Now it's important to note the shared responsibility model here again. This doesn't provide you logs for instances and applications like operating systems or things up in your portion of the stack, like your apps and the users of your web applications or enterprise applications. This is logging for the platform itself. So API calls made against AWS to launch instances, create resources, change networks, things like that. So the console has vastly improved from a visibility, or rather a UI UX perspective. You can look, this is just one event. I've filtered it on a particular event name. But this is an example of a CloudTrail log. And it shows me exactly which access key was used, what the event name was, or what the API call was that was made. So again, every single API call gets its own event in CloudTrail. And you see the full request and full response. You can see who made it, that was me. See where I came from, the time, and then the resources that it referenced. So in the full request and response of the API call, you see the resources I'm trying to impact. So just having a log entry is one thing, so-and-so logged in, so-and-so authenticated, but knowing what they were trying to affect is very important as well. This is the raw event. Everyone loves to read JSON, right? So it makes it easy to take this event and parse it, do other things with it, put it into your SIM platform, put it into a log management platform. CloudTrail launched with, I believe, 11 or 12 different partners, which means that they can read those logs and provide meaningful data and rendering and views and alerts on top of all that data. But again, you can see one important factor here, if I'm a security professional, and in the last event there, I noticed that someone put a policy or changed some of my identity policies. But I also note that this user was authenticated by multi-factor authentication right there in the middle. And you can filter on events to say if someone changes policy or someone changes a security group, was it authenticated by MFA? And if it wasn't, you can go and course correct and say, well, why is the user able to do that without multi-factor authentication? We integrated CloudTrail logs with CloudWatch logs slightly before reInvent last year. And it was a feature that maybe got a little overshadowed by some of the great stuff at reInvent. But it's a very cool feature if you don't want to take just the CloudTrail logs and put them right into your SIM or your log management platform in bulk. You can filter them through CloudWatch logs first. There's an excellent technical page in the CloudWatch logs, or rather the CloudTrail documentation, that provides a full setup of this kind of out of the box, the CloudFormation template. I really encourage you to find it. We can put a link somewhere. And it allows you to set up a bunch of sensible defaults for alerting and filtering in CloudWatch logs of the CloudTrail events. So this is an example where I've built filters of the logs. So I've sent my CloudWatch logs, or CloudTrail logs, to CloudWatch logs. And rather than have to store those logs, I can process them directly in CloudWatch logs. I've set up 3 filters here, for example. Anytime someone lists my roles, puts group policy, or puts role policy, or attaches those policies I was showing you earlier to my roles, I get an alert. This is just an example. You can send this to some automated system, but the email is just an example of what kind of alert and the data that you would get in it, which provides very actionable intelligence of what changed. So back to that problem of why security is hard, you know exactly what changed. The AWS CloudTrail covers almost every single API or every service almost now. It's expanded around the world, and it provides a very clear indication of what happened. So we encourage you to turn on CloudTrail by default, consolidate those logs in one region, and turn on CloudTrail in every region. So config. Config's a service that's designed to provide time series change deltas to change delta information or change diffs about your infrastructure. So think of trying to do this in a traditional environment. If my patch panel and my rack and my router and my switch and my servers all needed to give me one common way of telling me that they changed, that would be a very, very difficult task. With AWS config, you get a sense of all the things that are changing, all the storage, all the networking, instances launching, and the relationships between those. So back to my VPC here. I see that someone has added a public subnet, 1C, for example, and that's attached and associated with the internet routing table. They took the default route table off because my default was a secure, non-routable default subnet route table, and they added the internet routing table. Whoa, that's putting something on the internet, creating a bunch of new IP space. Was this change authorized or not? Was it intended? So, and this is something we're very, very proud of. I think for a security person to see this, it's kind of, you've kind of been waiting for it for probably a couple decades, which is to say, my infrastructure changed, here's the time series view of change by the exact time of change, and exactly what happened in terms of the relationships. It allows you to see not just the CloudTrail event of the request and the response, but actually what was before and what was after. So that ability to detect change, easily roll back, and easily iterate to control the impact of an unintended change is right there. You know exactly what changed. So you can see the relationships too, not just that the VPC changed, which is how I've selected it on top there, but you can actually see the subnet that was the one that changed. So it went from null, there was no subnet, to one that is now a subnet in that VPC. I can also take a different pivot on this view. So I can look at it from the perspective of that subnet. So you can see in this particular change that when you create a new subnet, it gets the default routing table for a VPC. But someone intentionally removed that one from the network ACL and the route table at the bottom and took them away and then eventually added them back to the internet one. But this is the first change. They created it at 908 and then 1 second later changed the route table. But I know exactly what it was before and after, and I can put it back if I want to. So tagging and asset management. I remember when we talked about why security is hard to detect change, it also relies on near-perfect asset management. That in a traditional environment, there's always a bit of a disconnect between the CMDB or the asset record and what's really deployed because it's soft data, and someone has to enter it and keep it up to date. Or you put an agent on a host somewhere that reports in asset information, but if that agent dies or the box gets turned off, the agent is kind of orphaned, right? That's traditional environments and how asset management's done. Or you can do ping sweeps and things like that to find assets and do asset discovery, but there's always a not 100% view of the asset inventory. With AWS, you get this view of attributes, and there's a lot more attributes than these. These are just the ones in the console. But all the private IPs, the image that it came from, so that image ID tells me what master image it was used to build the servers. And so you can see I've got quite a bit of configuration drift in this account. I'm not using all the same image. So that's something that I might want to shut those down and start new instances. For a security person, too, I've also tagged. I've encouraged engineers, for example, or you could, to tag your instances with a data classification. Now, this notion of a higher trust environment, right? How do I trust developers to not move sensitive data around? But if I give them a tool to tag the information, it's easy. And when they launch the instances, they can tag that information. They can tag the instance with the data classification. And I can apply security controls differently based on that tag. I can also respond to events based on the tag of that instance. So if I know that an event log or a message is coming from an asset related to a red data classification, I might want to prioritize that or act differently. I've also noticed there someone put yellow sensitive data. I might just arbitrarily call these red, yellow, and green data classifications, right? Very sensitive, maybe public information. But someone's put yellow information down there on something that's got a public IP, right? That's something I might want to investigate. So for example, right? It also allows me to change organizational behavior, right? If I don't know where data classification is, so these untagged instances here, I can automatically shut those down, right? And that will change behavior very quickly. So you let your engineers or developers or whoever launch instances in private subnets that are secure, but then you have additional sort of accountability, if you will. So you can launch as many instances as you want, just classify them, put data classification tags on them. And if they don't do it, every half an hour, it shuts the instance down. You know what will happen? Is people will tag their instances, probably immediately. So the other thing, too, to move quickly is to inherit compliance controls where you can. So we have a large number of certifications, PCI 3.0, ISO 27001, 9001. We do a SOC 2. We take that very seriously. It's our customers expect it. We've also been ahead of the curve on some of these. So mapping those AWS certifications into your enterprise governance, risk, and compliance, or GRC tools, is something that every enterprise does kind of early on, at least the ones who are moving very quickly. That way there's not questions about does AWS and the use of the cloud meet certain compliance requirements. We already know if you map it to your GRC that our controls can be inherited or rolled into your compliance program. So the next time you have an audit of an application, you get the controls out of our certifications where we're responsible, and it reduces the amount of control compliance work that you have to do. You don't have to select as many controls. You don't have to operate or prove or attest to the effectiveness of as many controls, which makes you move quicker. Also jurisdiction. So knowing where your data is something that's very possible in AWS. We have 11 regions around the world. You can move your data, you can move your data from region to region, but we will never do that. So if you put your data in US East or Frankfurt or Dublin, it stays in that region. We've made it easy with various features to copy data between regions, but again, that's your portion of the shared responsibility model and something you can completely control and audit and get a full sense of where the jurisdiction and governing laws are for your data. We also have regulatory and contractual options that help you move more quickly. If you're entering a new market, processing card data, dealing with protected health information, moving to a business model that takes European citizen data, which requires a data protection addendum. Those are all possible, and some you can talk to your account representatives about. But again, those contract options are something that help you move quicker in terms of security. Also, riding the pace of innovation. We talked about those 3-year strategies. We've seen a lot of these where customers aren't really encrypting their data internally, right? There's legacy applications. It's one of those things that key management is very difficult to do. It's very expensive to get started. It takes a skill set that most organizations don't necessarily invest in. Find things like that where you wanted to do data at rest encryption for sensitive data. You want to do data location or data discovery. And then if you're moving data to AWS, you can tag the data and you can tag the EBS volumes or the instances that host that sensitive data, which moves the curve and takes the innovation that we put into the platform and allows you to move more quickly. So for example, encryption is built into EBS, S3, RDS, Redshift, Glacier, Elastic MapReduce. Those are all a varying degree and spectrum of how you want to manage the keys, and I'll talk about that in the next talk I'm doing later today. But it's built in. So if that's on your 3-year roadmap, if that's in your strategy to start doing data at rest encryption, it's easy to do that. We have the key management infrastructure in place. It's one of those areas where you can take advantage of the innovation. We launched around 190 security-related features. About the over 500 features and services we launched last year in 2014, about 190 of those, I believe, had some impact on security and compliance or management. So usually identity, config, some of the CloudTrail expansion, new features in CloudTrail, all those things are, just by using the platform, you're inheriting a pace of innovation and security that's difficult to achieve in any other way. Again, it's about helping you move more quickly. So we talked about detecting change. We talked about reducing the impact of change. And we talked about getting teams together and cutting down some of the handoffs and processes. But if the changes are still very large and you put a lot of value into each change, the risk of those changes still stays high. So DevOps has kind of gone this way, but how do you use AWS to get those small batch, faster, incremental changes? So we'll talk a little bit about that. The pattern, though, and Stephen talked about this too a bit, is infrastructure as code. It's checked into source control. So every time you change a parameter in a CloudFormation template, CloudFormation allows you to templatize your entire architecture. So you can set up the VPCs, you can set up route tables, you can launch instances, build auto-scaling groups, basically provision any AWS resource or object in a template and launch that template as a piece of code, essentially. So it's a template, it instructs the CloudFormation service and the other services on what to provision. So that can be the object you check into source control, and you can audit that and see revisions in source control when something changed. People are also doing cutovers using Route 53 or Elastic Load Balancer. So you launch a new version of application, launch a new Elastic Load Balancer, or roll the instances out from behind the load balancer, and then move them over for things like A/B deployments or blue-green deployments. Elastic Beanstalk offers you application versions. So every time you build or do a build of your code, you can deploy that into a container on Elastic Beanstalk. And companies, they're integrating teams across these functions, right? So you have the network security team, you have the server security team, you got, the security operations center. We see a lot of large enterprises integrating those teams into consolidated either centers of excellence or app teams or kind of run-fast teams. And it brings the people together, but they have a far greater awareness of each other, and they can control and have lower risk changes. But you have to have a platform that facilitates those small changes. So back to my VPC, I'm looking at the tags on that VPC now. This was created automatically. So all those subnets that you saw, except the one that someone created when I didn't want them to, which we saw in config in CloudTrail. This was created with a stack, so an application stack. This was a template. It created all those subnets with all the tags that I wanted, with everything it wanted, all in one template. So if I version that template, I can create a new VPC. We have customers that are not just rolling out code in some cases, but when they do a build, when they ship a new feature or a user story in an application or they feature flow for the business, they're actually launching the entire network in some cases over again. Many people just have a VPC and they'll launch instances into it again and treat the server as a piece of code or something that they basically bundle and automate that deployment. But you can do the whole thing for the entire VPC, or just you can use updates as well using CloudFormation. So again, this is a view of the CloudFormation console and all the resources that were created by it. So again, I didn't manually go in and create subnets. I didn't have to put a config on a router or a switch somewhere. I didn't have to build servers by hand. So it comes down to automation. So the reason member security is difficult and challenging in traditional enterprises is because many of the things that are required to do security right are not conducive to automation. But here you can see every single one of these resources. So internet gateways, bastion hosts, all the firewall rules, all the subnets were created automatically just using a template, which allows me to automate my environment. It also means that I'm doing everything early in the stage. So if I need to make a correction, I don't have to go and I can just destroy what I built. I can take the infrastructure down because it's just done in a template. I go back and I fix it in source control, and then I redeploy it. It allows for very small incremental changes. Even if I get one parameter wrong, I can fix the whole thing. So reducing the impact of failure. So multi-availability zone deployments. Solution architects are measured on how well our customers are architected. So we don't consider you well architected unless you're in multiple availability zones, which means that if an instance fails or some application fails, you've reduced the impact of that failure because you have another copy of it, either in an auto-scaling group or another instance deployed, or a fleet of instances, for example, in multiple availability zones. If business criticality necessitates that you be across regions, or that you need to be closer to your users for latency or whatever reason, you use multiple regions. Many people will have a production instance in multiple availability zones, so you achieve kind of this active, or hot mode in one region, and they'll back up data to another region and have a pilot light or some other smaller instance, or even a whole copy of that, maybe in CloudFormation that they can spin up and take advantage of that data should they need to move globally or deal with resiliency in one particular region. We make data replication easy. Availability is a key part of security controls, so using replication features where they already exist. So S3 facilitates this, EBS facilitates this, RDS makes it part of the platform where you can replicate that data. And again, that's about reducing the impact of failure. Auto-scaling and auto-recovery features of auto-scaling, or auto-recovery rather, allow you to have instances that can fail, or when load increases beyond what you anticipate, you auto-scale. So the failure doesn't come from a good day for your business. If your business is getting a lot of traffic and you need to scale up, you can do that. So again, it's about further improving automation. The key thing we want to encourage is that access and deployments are no longer performed by people. And that's what I think the customers and the enterprises who are moving and evolving their security programs have embraced the most, is that automation, it's a better investment to automate things early on so you can make those iterative incremental changes than it is to have people log in and fix something directly. So the days of the server's freaking out or something and I log in and I troubleshoot that server, they're kind of over, right? People are not, they're not logging in. If you don't need access, if you don't provision access to a server, no one can log into it, which improves the security bar immediately. And if you have the assumption that all logs are going to get centralized, that if there's a failure, you're going to blow the server away and spin up a new one either using auto-scaling or something else, and you fix it in the build process and allow something like code deploy, or you allow something like CloudFormation to go and deploy a new one, or Beanstalk, or whatever, wherever you fixed it, you push that fix out as a server or as a version of an application, but you don't log into the box to fix it anymore. And that's the pattern that people are really embracing very quickly. It also means that you can use EC2 roles and instance profiles, identity assigned to an instance to take actions. So instead of having a user, when the server comes up, log on and put an SSL certificate on a web server or put a credential in for a database connection string, you do that through code. And you do it through bootstrapping processes of the instance. We launched AWS Code Deploy, which is a very powerful tool. It allows you to roll out application changes to small deployment groups within your infrastructure. So IT is all about applications for the business, right? So if you keep your mind on that, then the fact that you can roll out to one instance, a single instance in an auto-scaling group or a set of instances, 100 or 1,000, you can roll out to just one and measure the impact of that change. So it's about small, low-risk, incremental changes. You've pushed your application with Code Deploy to just one box in your deployment group, and then you maybe roll it out to 10%, and then 20%, and then 50%, and you can slowly roll out an application using Code Deploy in a way that you detect failure early, and you'd be able to course correct and roll it back easily. Companies are definitely, and this is, Bay Area, everyone knows this probably, but they're embracing continuous integration and deployment heavily, and they're doing that on our platform. So making Code Deploy part of that, making the infrastructure part of that, or using things like Jenkins. Most people are doing their deployments and their infrastructure automation through a CI/CD pipeline now. And that reduces the need for long-term privileged credentials to the infrastructure, which is great for security and audit, but it also means that you course correct very incrementally. We've also extended Code Deploy to on-premises workloads. So you can have a Code Deploy agent running on instances in your own data centers that can now connect, and it only reaches out from your data center. Nothing talks into your data center. You can have a Code Deploy agent talk up to the Code Deploy service on AWS and get application changes and make it part of those deployment groups. So now you can have those incremental small changes, not just in AWS, but in your own data centers as well. We're talking, I think maybe right next door is the hybrid architecture talk. And I think these are being recorded, so you can watch that too. But there'll be a combination of network connectivity for some things. But even with Code Deploy, you don't need connectivity network-wise. You just need a connection to the service. So making security actionable is what I'll conclude with. Reviewing what matters. So there's a lot of noise in security. There's a lot of event logs. There's a lot of information. But how do you know what matters? So thinking about AWS, where are the areas where if my controls fail or things change, I'm most exposed? So looking at changes where internet gateways exist. If that means that you have a path to the internet. You also need open security groups and you need a public IP, but that's a first indicator that something, something has a connection to an untrusted network. Identity and access management. So changes to policies, changes to users, groups, and roles, or encryption keys, for example, are something you want to review and have CloudTrail alert you on immediately. VPC, subnet, and NACL changes in security groups, those change the security posture and the attack surface of your instances. Those are things you'd want to alert on automatically and take action on. But what do? You can shut them down automatically. It's about that stimulus and response. So you can have events come from the security groups or things in CloudTrail and then take action on it, either using Lambda or using some other web service that you've built to respond to those events. So when things change, you can again, you know exactly what changed, you know when it changed, and you can roll it back incrementally. So not just reacting to what changed, but assessing what changes as well. So again, we mentioned that audit is just an API call away. It's about automating not just the infrastructure security, but also the compliance as well. So it's kind of widely known, that compliance is largely done through spreadsheets in most of corporate America. We think that you can automate that and make it better, move faster. So when something changes, rather than auditing and doing a census of of the entire environment every quarter, audit incrementally. It's continuous monitoring, continuous compliance, so you know exactly what changes. And if a control changes, you don't have to wait till the next quarter or the next release or the next annual audit to find out. And use things to roll back automatically. So go back to your sensible defaults. Go back to your CloudFormation templates. If something changes, if something isn't tagged properly or at all, you can roll it back and shut it down. So these patterns about, they really speak to what enterprises are doing, how they're evolving the modern security organization to take advantage of automation and take advantage of the cloud and change the behaviors. So it takes it back to, why does security come first in a conversation with enterprise customers? It comes first because fundamentally, in traditional enterprise security, things are hard to detect change, it's hard to incrementally manage change, and it's hard to reduce the impact of failure. But I think with AWS, you can see in certain ways how you can improve and make greater security on Amazon Web Services. The benefits, you get a high degree of visibility and transparency. You end up with a culture change as well. You end up with a lot more trust. If everything is visible and everybody knows what the developers are doing or the engineers are doing, you end up with a lot more autonomy, which means people can move faster. And those processes that were put in place because people didn't know what was changing and couldn't control or reduce the impact of those changes, those processes tend to get questioned, and they tend to be removed as blockers, and you take out those pause buttons in the deployment cycle. You end up with also significant reductions in long-term privileged access. If machines are doing everything, if there's no actual users provisioned, if you're able to shut down instances if someone logs in and rebuild it from scratch in the build process, it's good for audit. You focus a greater portion of your limited security resources toward application security. The infrastructure stuff is where most security and enterprise security teams spend their time, when they should be spending it on application security. Code reviews, where the data exists in the applications. But really, what we see the most is that companies who have embraced these patterns and question the processes that are there just to detect unwanted change, they're really achieving a much, much higher rate of successful changes. And the changes are delivered more quickly and more frequently with less risk. Gone are the days of quarterly releases or an annual update or a version. People are shipping sometimes dozens or hundreds of times a day. They're shipping code and deploying infrastructure and making changes, all with success and all with low impact with high degree of visibility. So thank you. Appreciate your time.